In this video, we're going to briefly go over matrix multiplication, specifically the multiplication in which you take two matrices and return a final matrix. So the first rule in matrix multiplication is understanding that the product of matrix A and matrix B is not always defined for all matrices A and B. More specifically, the specific dimensions need to be met in both A and B for the product to be defined. What those dimensions are is that the width of matrix A must be equal to the length of matrix B. So if we write matrix A as an m by n matrix, note that matrices are noted by the number of rows first. So we have m rows here and n columns. Therefore, A is an m by n matrix, and we let B equal to an n by k matrix with n rows and k columns. We're multiplying an m by n matrix by an n by k matrix. This works because the two middle numbers n and n are equal, and what this multiplication will actually result in is an m by k matrix. It's more clearly shown right here where you have m by n, n by k. So the first thing you need to figure out is if the two inside numbers are equal, and what it will result in is a matrix determined by the two outside numbers. The best way that I'm able to visualize this process is this diagram right here. So imagine we have A here and matrix B here. So what we're going to do is we first multiply the rows of A by the columns of B. That means if we go this way, take this row vector and take this column vector of B, this element where this row and column meet in the resultant vector is going to be the dot product of those respective column and row vectors. If you take the first row and the second column, this element here is going to be that dot product. Pretty much imagine it as grid lines with lines going like this and lines going like this. Each pair of dots represents a dot product that you'd arrive at with the respective row and column vectors. What this diagram also helps convey is the fact that these dimensions here, which is the width of A and the height or length, however you want to call it, of B, have to both be equal. So this space right here has to be square. If we extend this, then we wouldn't have enough elements on this dimension of B to match with the elements of A. So we can't have an unequal number of elements here. If we increase the height of this, it'd be too many elements that don't match up with the elements of A. I can show you better than I can tell you, so here's a quick demonstration of matrix multiplication with numbers instead of dots. So here we have a 1 by 2 matrix multiplied by a 2 by 3 matrix. Remember, this is valid because the inner numbers, the one dimension of A is equal to the corresponding dimension of B. So we have 1 by 2, 2 by 3, the inner numbers match, and this is going to result a 1 by 3 matrix. We're going to dot this vector with the first column in matrix B, and that's going to give us, this is a 1, 2 dotted with 5, 8, and it's going to give us 1 times 5 plus 2 times 8 is equal to 21. So that's the corresponding element in the resultant vector. And we do the same exact thing with the next columns in B. But fortunately, this only has one row, so we don't have to do any more work after this row. In total, we're going to have 1, 2 dotted with 6, 9, and then 7, 10. We fill out each of those elements, and that gives us our matrix, our 1 by 3 matrix of 21, 24, 27. Eventually, you'll find that this operation does get quite extensive. For example, look how many multiplications we had to do just for a simple 1 by 2 and 2 by 3 matrix. If you're wondering the general formula for how many times you multiply two numbers and then add all of them, it's going to be m times n times k. What that means is your three different dimensions. Sometimes you'll have a case where all the dimensions are equal, say a 2 by 2 times a 2 by 2 matrix. Your dimensions are 2, m, n, and k are all 2. So you have 2 times 2 times 2, which is 8 multiplications. In this case, it's 1 times 2 times 3 multiplications, which are 6 total times. you'll find that if you extend this to even a 3 by 3 times a 3 by 3, it'd be 3 times 3 times 3 is 27 multiplications. So yeah, optimally you find a calculator to do these multiplications. If you have to do it on a test, hopefully your teacher gives you small matrices. We'll explore how useful this operation becomes when we talk about rotations, transformations, and other linear algebra concepts in which matrix multiplication are needed. And yeah, so just remember this is how you do matrix multiplication, and later we'll talk about where we can use matrix multiplication.